Hello. In this video, we will be going over how to set up Loki with Grafana to ingest our service log similar to how we used Prometheus to ingest metrics. If you do not already have Grafana set up, please watch my previous video linked in the description before continuing with Loki. If you find this guide helpful, please like and subscribe. Let's get started. There are two services needed to get Loki working. The first is Loki itself, and the second is Alloy. Alloy is used to collect and send the logs from your services to Loki, where Loki then aggregates, labels, and stores the logs. Before we install Loki and Alloy, let's create a configs dataset to more easily access and update our configs. We'll be using a similar setup as we did for Prometheus in the previous video. Back in our TrueNAS console, under Datasets, let's create a new dataset. I'll call mine configs and set the dataset preset to apps. Go ahead and save the dataset. Let's create another sub-dataset in configs called Loki with the same apps preset. When prompted to set ACLs, simply return to the pool list. Now that we have our Loki config dataset, let's SSH into our NAS and create our config files. I'll have all the config files linked in the description. Navigate to the Loki dataset and create the Loki config using vim localconfig.yaml. Hit insert to enter insert mode and paste the config link below. This config essentially runs Loki on port 3100 without authentication and sets the replication and storage config for our log data. If you would like a deeper dive into the configuration, I'll have some documentation linked below. Go ahead and save the Loki config by hitting escape to exit insert mode, then :x enter to save the file. Now let's create our alloy config. Use vim config.alloy to create our config file and paste in the config from below. This config serves two main purposes, the first of which is finding all of our logs, and the second is sending them to Loki. We will be updating this config later in the video, so for now I will use the basic Docker config. This will allow Alloy to access the Docker socket, enabling it to see other containers running on our system and access their system out logs. One main config to point out is the discovery relabel block. This takes the metadata container name we receive from our targets and creates a filterable label based on the container name. This is crucial in being able to filter out our container logs. We will also set the Loki endpoint to send the log data. I will have documentation linked below if you would like more information on Alloy configs. Go ahead and save the configuration. Now that we have our configs, let's deploy Loki and Alloy. We will deploy Alloy and Loki through Docker using Portainer. If you do not have Portainer or another Docker manager installed, please install Portainer through the TrueNAS apps before continuing with the video. Over in Portainer, let's go to our local environment, stacks, and add a stack. I will name mine Grafana and paste in the Docker compose linked below. This will deploy both Loki and Alloy. For both services, we are exposing the needed ports, as well as setting the config file paths. You will need to update the volume paths to your local config dataset path. One other value to validate is the app user ID for Loki. By default, it should be 568. We can validate this by heading to our TrueNAS UI, under Credentials, Users, toggling the Show Built-in Users, and searching for apps. Validate the user ID in Loki matches the ID for the app's user. In this case, 568. Once validated, go ahead and deploy your stack. Now that our services are deployed, head over to your NAS IP on port 12345, and you should be greeted with the Alloy UI. You should see a couple components, which are all the components from our config file. Go ahead and view the discovery.docker.linux container. Here we can see all of the targets this component found. Scrolling through the list, we will see all of our other running containers for services such as Image, Jellyfin, VaultWarden, and so on. As we did with the container name, you may create labels and filters based on any of the metadata fields in the targets below. Now that we had a look at Alloy and confirmed it is pulling our containers, let's head over to Grafana and look at some logs. Similar to Prometheus, we need to configure the Loki data source before we can use it. Head over to Connections, Data Sources, Add New Data Source, and search for Loki. Update the connection URL to your Loki service. This should be your NAS IP with port 3100. Save and test your connection. Once successful, let's head over to our dashboards and create a new dashboard for this demo. Add a visualization and set the data source to Loki. The querying UI is the same as in the previous video with Prometheus. We have the builder and code methods for creating queries, as well as the visualization configuration options on the right side. In the query builder under labels, we have a couple labels to filter. The container name is the one I will be using and was created by our Alloy relabel config mentioned earlier. Under values, we should see all of our containers for the various services we have running. You may notice some containers are missing. This is likely due to the time range. Increasing the range from 6 hours to 30 days adds a bunch of container names. Loki will only show the values that exist for the selected time range. There are ways around this we will go over shortly. Let's take a look at my Jellyfin service logs. We can see all the logs for the past month as they would appear in the Docker container itself. This alone can be useful as a way to view logs. However, the real power of Loki is the ability to create dashboards based on these logs. This is ideal for services that do not have a metrics API or other built-in methods to extract metrics. For example, what if I wanted to have a dashboard for my Vintage Story game server? This service does not have a built-in metrics API. Looking at the container logs for Vintage Story, there does not seem to be much useful information. This is because we are not directly accessing the server logs, only the container logs. This is a key point to keep in mind with Loki. Unlike Prometheus metrics, logs can exist in many different forms and locations within a service. Let's update our Alloy config to pull the server logs directly. Back in our Alloy config file, I've added the two following blocks: the local file match as well as the local source file. The local file match will look at the local file path specified and pull in all relevant files. The Loki source file block will take these files and forward them to our Loki service. I will have documentation for all of these configurations linked below. Once our config is saved, let's also update our Alloy container to have access to the log files. In our Grafana stack, I've added a volume mounting our game server logs to the Alloy VS logs path we used in the config file. Once we update our stack, Alloy will now pull our log files directly. Back on Grafana, we now have a new label file name. Looking at the values, these are all of our Vintage Story server logs. Let's take a look at the debug logs. The information I'm interested in are all the mods currently installed. I would like to have a dashboard for the number and names of currently installed mods. Scrolling down, the logs with this information are the 26 assemblies loaded, as well as all the instantiated mod systems before it. With Loki, we can query for these specific logs and parse the lines for the information we need. For getting the number of mods, I will use the following query. This will go through the logs and create a new label mods for any log that matches the regex expression. If you would like a video going deeper into specific query configurations and methods, please leave a comment below. After running the query, we can see the new mods label added for the assemblies loaded log. Now let's use this label to create a nice visual. We will do this by adding a transformation to convert the label into a value we can use. Under transformations, add the extract fields transformation and set the source to labels. We will now see a new column mod with 28 for our assemblies loaded log. We can now create a visualization for this. Change the visualization to stat and update the fields under value options to mods and the calculation to last non-null value. We now have our mods count as an easy to read number. Before we continue, let's set a constant time range for this panel. The reason for this is if we change our range back to 5 minutes, for example, we get no data. This is because these debug logs are not constantly generating, so will not necessarily be within the shorter time ranges. To set a panel time range, go to Queries, under Query Options, and set the relative time to now/M. This panel will now always look over the past month for the data. Let's go back to the dashboard and add another visualization for the mod names. Again, set the data source to Loki, and I will use the following query to get the names. This query takes the last word of each line that matches the regex expression and sets that word as the line data. Taking a quick look at the data, we can see this essentially sets each line to an empty value except for our mod names. I will then use the filtered data by values transformation to only include logs with a non-empty line value. We now only have our mod names in the table. Let's update the table visualization to remove the other columns. At the very bottom of the visualization config, we add an override for names matching the regex expression and set the regex to select names except for line. We then added an override property to hide in table and toggled it on. We now only have our lines column. Up at the top top of visualizations, we can also toggle off the show table header, as we do not want the lines column header showing. We can then name our panel mods, and then back in our query options, let's also set the relative time to 1 month. We can then go back to our dashboard. We now have a dashboard for our Vintage Story server that shows the mod count as well as the list of mods. This is a basic example of using Loki and server logs to create dashboards for metrics you may otherwise not have access to. From here, you can add more log files to Alloy, create more dashboards, or update existing dashboards to utilize logs, and even add alerts based on log data. If you found this video helpful, please like and subscribe as it really helps out the channel. Leave a comment with questions or future topics you would like to see. Thank you for watching, and happy self-hosting.